Hello grade 11 GED 2019-2020 students. We are in topic 4. This is electric fields, and this is the first lesson in electric fields. We have 4.1 as mentioned in your syllabus, Coulomb's law. Our objectives for today are to recall and use Coulomb's law to solve problems about electric fields, force between 2-point charges and exerted by 2 charges on a third one. So mainly we have to define Coulomb's law and to use that for solving problems. What is Coulomb's law? Let's state Coulomb's law, then we are going to discuss. Any 2-point charge exert an external force on each other. That force is proportional to the product of the charge and inversely proportional to the square of the distance between them. Okay, what does this mean? We have here 2 charges, for example, point charges Q1 and Q2 separated by a distance r. Now, each of these charges exert a force. We call this as electrical force because it is due to electric charges. So each charge exert a force on the other. Q2 will exert a force on Q1 and Q1 will act a force on Q2. This force, which is F, is directly proportional to the product of their charges. So the force is directly proportional to the product of their charge, and the same force is inversely proportional to the square of the distance. The distance is r, so the square of the distance. This means that if the product of the charges Q1 times Q2 increases by increasing any of the charges, S will increase. And if the distance between them increases, then the F will decrease. So, according to Newton's third law, the point charges interact with each other, so they exert equal, therefore they exert equal but opposite force on each other. It means that the force that Q1 exerting on Q2 equals to the force that Q2 exerting on Q1, but in opposite direction. So there is an interaction force between them. Both forces are equal and in opposite direction. This force can be repulsion if both charges are similar to each other. For likely charge, the force will repulsion, and for the unlikely charge, the force will be attraction. So for a positive with a negative, there will be an attraction force. For 2 likely charges, the force will be a repulsion. Let's come to Coulomb's law from these expressions. Now, F proportional to Q1 times Q2 over R square. and then we can replace the sign of proportionality by a constant. F equal to constant Q1 Q2 over R square, and you know that our charge, the unit for charge is Coulomb, the unit for R is meter, the SI unit, and that's why the force will be measured in Newton. Let's go to see what is this constant means. So this constant is K, okay, so which is equal to 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Here we are considering that there is free space between both charges. So if they are a different material, for example, if we replace air and put the charge in any other material, so the value of permittivity epsilon naught, therefore the value for K will be changed. But here we are dealing with a certain K with a certain epsilon naught for free space. Here, if we are going to substitute with the value of epsilon naught, here this is the value of epsilon naught, so we will get the value for K, which is 9 times 10 to 9. Of course, Newton meter square per Coulomb square. So this is the formula that what we are going to use today for the force between two charges. This is the value of K, 9 to the 9, 10 to the 9 times 10 to the 9, Q1, Q2 over R square. Okay, now let's go furthermore with this formula. Now for F equal to K Q1 Q2 over R square, suppose if our Q1 times Q2 is constant, it means we are having the same charges, and so we have two charges, Q1 and Q2, with a distance of R. Suppose we are changing the distance between Q1 and Q2 by increasing or decreasing. So what will happen here, as you see here from this formula, there is an initial here, an initial distance between, be careful that this is R square. So there is an initial distance between Q1 and Q2, which is this. Okay. Now if we are increasing R, so R square of course will be also increased, therefore F will decrease. We know that they are inversely proportional to each other. So F again is inversely proportional to R square. It means when R square is increasing, F will decrease, and this will be the graphical representation of R versus R, F versus R square. But what if we are going to take the relationship between f and 1 over r square here. F with 1, so we said here that f with r square, they are inversely proportional. But what about f with 1 over r square? So if you are going to take the reciprocal of this, 1 over r square, f will be directly proportional with 1 over r square. Like if we have y is directly proportional to x. Our x here is 1 over r square instead of r square. So we are going to get a straight line. Okay. Now let's take here as a comment, we are considering a uniformly charged sphere. Okay, the distance here would be from the center of one to the center of the other. If we have a charged sphere, okay, a conductor sphere which was charged, of course the charge will distribute itself so it is on the surface of the sphere. So if we have two charged spheres, we are considering the distance between them to be from the center to the center. So that's why for any point outside the spherical conductor, the charge for the sphere may be concentrated here. So till that point. As an example, okay, now we are going to calculate the electric force between 2-point charges. We have 2-point charges. Okay, this is a charge and this is the okay, this is a charge and this is the other charge, Q1 and Q2. Calculate the force between 2-point charge, each of 1 times 10 to the 9 Coulomb. So they are both equal charges, where they are 4 centimeters apart in a vacuum. So we will use the formula F equal to K Q1 Q2 over R square. Now we are here dealing with Newton, so this should be in Coulomb and this also Coulomb, and R should be in meter. So our R equal to 4 centimeter, so divided by 100 it will be 0.04 meters, and this should be in Coulomb. It's very important to make sure that you have the appropriate units. So only by substituting, our K is constant, 9 times 10 to the 9, remember that, and it should be always given. Each of the charge is 1 times 10 to the minus 9 Coulomb. So we have 1 times 10 to the minus 9 times 1 to 10 times 10 to the minus 9, or you can square it. Divide by 0.04, and do not forget we have here square. This will give you 5.62 times 10 to the minus 6 newtons. Okay, now what is the type of the force here? As you see, here you have a positive charge and another positive charge. No signs, negative sign is here. So of course they will repel each other. So this is a repulsion force. So repulsion will take place here. So remember here, if you have positive with positive, the answer will be positive, and the positive sign here, it means that you have repulsion force. Even if you have Q1 is negative, the Q2 also is negative, so we will end with a positive sign. Again, positive means repulsion. Okay, now we are going to calculate the electric force exerted by two charges on a third one. So you have here three charges, and two are exerting forces on a third one. All are in the same line, on the same line. Let us do this example. We have here the figure opposite shows 3-point charges. This is Q1, Q2, Q3. So you have here Q1, you have here Q2, you have here Q3. Calculate the net force on Q2, this. You want the net force here. And determine its direction. Okay, now remember here that this charge Q2 is affected by two other charges, Q3 and Q1. Both are exerting forces on Q2. So there is more than one force here. Two forces are acting on Q2. We have to find each force, then get the resultant of both on Q2. Let's first determine the direction of the forces that are acting here on Q2. Now, Q2 and Q3, they are opposite charges. This is negative and this is positive. Now we are talking about the force on Q2 exerted by Q3. Now Q3, it's going to affect on Q2? It is going, of course, to attract Q2, because this is positive and this is negative. So there is an attraction force. Let's call this F, the force between Q2 and Q3. So the force between Q2 and Q3. The same charge. Now remember that we are here concentrating on the force acting on Q2. Also here, Q1 is positive. So how it is going to act on Q2? Again, it is going to attract Q2. So Q2 is attracted by Q3 and also attracted on the other side by Q1. So this is the force between Q1 and Q2. So we are looking on the forces acted on Q2. There is a force by Q3 and there is a force by Q1. So we see that this charge Q2 is under two opposite forces. We have to calculate each force, then get the resultant force. Okay, let's calculate F1, 2. So our F12, again we have K, Q1, Q2 over square root, the square of this distance between them, which is 200 centimeters. And so the distance 200 centimeter should be convert to meter, so it will give us only 200 divided by 100, it will be only 2 meters. This is this R. And we have another R here, 400 centimeter, which should be 4 meters. So the distance between here and here, when doing any problem, the first thing here to see the directions of forces, then to see if you have the appropriate units. Okay, this is the distance between Q1 and Q2, and this is the distance between Q2 and Q3. Yes, and all your charge should be in the unit of what? Coulomb, and you have here microcoulombs. So for when we are converting from microcoulomb to coulomb, we have to multiply by 10 to the minus 6. Okay, we have here R square. Let's substitute. Our K is 9 times 10 to the 9, constant. Our Q1, here, this is our Q1, which is 4 microcoulomb. So, it is 4 times 10 to the minus 6. We are converting it from microcoulomb to coulomb. Our Q2 is minus 5. So, times minus 5 times 10 to the minus 6, again converting to microcoulomb and dividing by the distance between them, which is 2 meters, and we have a square. This will give us the value for the force between Q1 and Q2, which is minus 0.04 5 newtons. What this minus indicates? It indicates that you have here a positive times negative, so it is an attraction force, so the minus gives us the type of the force only. So remember, when you have positive times positive, it is positive, so it's repulsion. Negative times negative will give us also positive, so again it's repulsion. So positive means repulsion force, but here we have a positive with a negative, so we are getting negative force, so it is attraction. So, okay, now let's calculate the other force. between F2 or exerted by F3 on F2. So between F3 and F2. Again, the same formula with substituting with the correct values. We have K, 9 times 10 to the 9 time. Now we have our charts, Q1 and Q2. This is Q1, which is 6. Again, converting it from microcoulomb to coulomb, 10 to the minus 9. This is Q2, which is again minus 5. Converting it to coulomb and dividing, where is the distance? This is the distance between them, 4 meters. Sorry. Square. And this will give us the force of minus 0.017 newtons. Again, this minus only means that there is an attraction force between them. Even if you are not going to write it, it is fine. So, for okay, now here, for example, for the previous question, if you have a positive with a negative, and this will be negative, even if you are not going to write it here, and just mention that there is an attraction force, negative, that's fine. So you either substitute with the sign, and you are going to get here, if there is a positive with a negative, you will get a negative sign. Or you only substitute with the positive values, so you will get a positive, and you can mention the type of force. If both are opposite, so it's attraction, and if you have the force between two similar charges, so it will be a repulsion. Now, how to get the resultant of these both? As you know, from the vectors, you have one charge, one force, sorry, to the right, other to the left. So what you are going to do, just subtract, okay, subtract one force from the other, and the direction will be the towards the largest value. So you have here one force. This is one force. Consider the value without the negative sign. And this is the other force. Where is the largest value? This is, okay, which is between F1, 2 here. This is greater than this. So the net force will be 0.045, the greater value, minus the less value, this, okay, 0.017, again without signs. Signs only show us the type of force. If it's negative, so it means there is attraction. If it's positive, it means that there is repulsion. So take here the values for forces without any sign, and this will give us 0.062 newtons. And where is the direction here? Towards the greater value. Where is the greater value that we have? This, between F1 and 2. This is the largest. So the direction will be to F1, 2. So to the left side. Now in this example we are still calculating the force exerted by two charges on a third, but they are not in the same line, on the same line. They are forming a triangle. Okay, so here the figure opposite shows 3 point charges. Here Q1, Q2 and Q3, and we can use the capital notations as it is mentioned in the formula in your book, but it's fine to go with the small q even, just to make them similar to whatever you have in your formula. Q1, Q2 and Q3, and they are asking to calculate the net force on Q2 here. This is the Q2. They want the net force here and with its direction. Now, first of all, we have to see or to come with the directions of the force exerted on Q2. Now, Q1, how it is affecting on Q2? This is negative and this is positive. So Q1 attracting it, yes, with this direction. So this is the force between 1 and 2, exerted by 1 on 2. Let's see the other force. Here Q3 is positive and Q2 is also positive. So how this Q2 affected by Q3? Q3 is going to repel it to this direction with a force between Q2 and Q3. So there is a repulsion force. Be careful, we are only looking the forces here at this point. So it is affected with by a repulsion force from this Q3 to this direction, repelling it, and attracted by Q1. Now we have to calculate each force separately as we did in the example before. But before going, we have to come with our units as we mentioned. This is 8 centimeter, so 8 divided by 100, it will give us 0.08 meter SI unit. This will give us 0.06 meter. This will give us 0.1 meter. Let's come with the Q's. Our Q is here in microcoulomb. We have to convert microcoulomb to coulomb by multiplying 10 to the minus 6. So Q1 should be minus 5 times 10 to the minus 6 coulomb. Q2 is 4 times 10 to the minus 6 coulomb. Q3 equal to 3 times 10 to the minus 6 coulomb. Now let's come to our example. So we have to find first of all F12. F equal to K Q1 Q2 over R square again. Now what is our F1? F1 is between minus 5 and positive 4 here, Q1 and Q2. So F between 1 and 2 equal to K, which is 9 constant, this, times 10 to the 9. This is our constant. Times, we have our Q1 and Q2s here, Q1 and Q2, minus 5 times 10 to the minus 6 times 4 times 10 to the minus 6 divided by the distance here 0.08, and do not forget the square, and this is going to give us minus 28 Newton. Remember, this minus only indicates that there is a attraction. So it doesn't mind if you are not writing the minus sign here. So only mention that there is an attraction because they are having opposite, Q1 and Q2, they are having opposite signs, opposite charges. Now let's go for the other force. Here F between Q2 and Q3. Q2 and Q3, again the constant 9 times 10 to the 9 time. Comes to the Q2 and Q3, these are the values 4 and 3. Yes, we have the values 4 and 3. So we have 4 times 10 to the minus 6 times 3 times 10 to the minus 6. Divide by the distance between them is this 0.06 and square, and this is going to give us the value of 30 Newton, and this is positive. It means that it is, because you have positive and positive, you are getting positive, so repulsion. Okay, they are not asking us what are the type of force here, only for making things more clear. But now we have to find, we have two forces, how to find the net force here. Going back to the vectors, you know, if we have two vectors in the same direction, we have to add them and the net force will be in the same direction. If we have two forces in opposite direction, as we had in the example before, we have to subtract them, and the net force or the net value will be net force will be in the direction of the greatest. But here we have F1 and F2, which this is F1, 2, and this is F3 and 2. They are two perpendicular forces. Yes? So for two perpendicular vectors, how to get the net force? We have to here complete or draw our parallelogram. And this is the net force. Okay, this is our net force. So to calculate the net force, F, remember that we are having here a rectangle with a right angle here. So what we have to apply here, the Pythagoras theorem. Pythagoras theorem states that the square of the hypotenuse, which is F, equal to the square of the other sides. This side and this side is the same as this, F21, and this side F23. So it is F12 square plus F23 square. So if we want only f, it will be the square root of f12 square plus f23 square. So it means our f here, f12 root square of f12 square is this 28 square. Even you are going to take the minus sign, then it will go with the square, and it's okay to take only the quantity. And this 330 square, and this is going to give us 41 newtons. So this is the value of the resultant force. Now, how to get the direction of the resultant force? They are also determine its direction of F. For the direction of F, we have here to come with tan theta. Where is our theta? Here, this is our theta here. Tan theta equal to the opposite side, which is F12, divided by the adjacent, which is F23. So it is F12 divided by F23, which is 28 divided by 30 will give us, now this will give us tan theta. To get theta, you have to get the shift, of tan theta of 28 over 30. This will give us the value for theta, which will be 43 degrees. So it is, so do not, remember always, tan theta equal to here, the opposite vector divided by the quantity here, divided by the adjacent. But this is going to give you tan theta, not theta. To get theta, you have enter in your calculator shift tan 28 over 30, or the value that you are going to get here, and this will give you the value of theta, which is 43. So we say that the force is making an angle of 43 here with this axis, or with F23. This was our the end of our lesson for today. Thank you.